Uh, Hello, everyone. Our next talk is from Gulcin, and she will be speaking about what you should know about constraints in PostgreSQL. So the stage is yours.
Thank you, Honza. And I will use Myers trick. Dobry den, imenujse Gulcin, and that's it. I wish I knew more, but I'm really failing in this language. I'm living here for so long, and I'm embarrassed to say it that I'm living here so long. But consider me a local who is disabled in acquiring the language. And yeah, so welcome. As Honza said, we will talk about constraints today. This is the second time I'm giving this talk. First time was in Riga last year, so it's relatively new. And yeah, I hope you will enjoy it. Okay, so a bit of the agenda, what we will actually do today. We will talk about the PG constraint catalog, and there are developments regarding constraints in Postgres 18. And there are a few of them, and I thought it's a good chance to actually talk about them here. And I think given this lecture, we will use all the full length to talk about it. There is the main, I think, improvement is about temporal keys, introduction of temporal keys, because this was not a thing before PG18. NULL was not treated as a constraint, and now it is. It's promoted to be a first-class constraint. And there was not a concept of not enforced. We had a concept of not valid, but we didn't have the not enforced concept. Now we do. We will talk about that too. And there are a few improvements related to partition tables that we will at the end mention that. And I made a bit addition to the slides from the Riga. I also looked at the patches that's ongoing or discussions ongoing about the constraints that might end up maybe in Postgres 19. And we will finish with that. Okay, so who am I? I'm working at a company called Zeta. We have our own Postgres offering. It's running on CMPG. It has this modern functionalities like copy on write branching, data anonymization. We can scale because basically it's using same thing as vanilla Postgres, but added stuff on top of it. I started as a DBA for many years ago, and this year switched the gears a little bit to kind of influencing the Postgres product in Zeta. That's what we do. I got recently recognized a few years ago as a Postgres contributor. I feel it is such a heavy thing to say, and I hope I am deserving this. And if you live in Prague or around Prague, we are running Postgres meetups pretty much every month. We skip some summer months because attendance is pretty low. We skip Christmas time. But if you are here and if you haven't joined the meetups, please do. We are searching for speakers all the time. And we, I think, do a pretty good job bringing talent, Postgres talent from all around the world. And we had the recent one on Monday, this Monday, just before the conference with 3 talks. So there are many conferences happening about Postgres every month. Please do join us if you're interested. And I don't want to go too much about it, so let's start. There's a lot to talk. Okay, a bit of the emotional part. There is this recent trend about how was I 10 years ago in 2016. Definitely much younger, but I noticed this was 10 years ago. This was my first PTD2, the one on the top. I was like a young girl, I think I must say. And everybody thought I'm a sales engineer. Nobody came to my booth until I went to the people. I say, hey, I work in second quadrant. I'm actually writing an automation tool. I'm doing database as a service. This is like the infrastructure that I'm working on. Then people started to talk to me. So it was like very interesting experience for me. I still remember it. But overall, the year things changed. In where I eat Koblicek, I was like pregnant then, so it was 2019, and then it's just like life goes on, and I'm happy that I'm still here, still talking to this community. Okay, all right. This was a very long introduction. So what we will talk about today, constraints. So how many of I just want to see the room. Maybe we can separate DBA. Sysadmin ops roles versus devs. I want to see the devs first. How many devs? How many of you associate as a dev? Okay. How many of you associate non-dev, like DBA, SRE? Although there's not now we are almost always dev, but okay, so this is a good, I think, talk for this audience because I think you interact with databases more than Postgres developers do, right? The things that the experience that they are lacking, they are building the Postgres, the like Postgres contributors, they are building it, but they don't know the experience, I think, from the developer's perspective, how they interact with the database, what type of features they need. Of course, we have all this, discussions happening, but it's good that you are here, and that's really important that you are here so that we need this information a lot. And constraints is something I think people, probably you guys do with some ORM type of tools. I don't know with the AI tooling, how does it change now, but me, when I was database engineer, I was just writing directly on the database, writing SQL. But recently, as I said, I joined a few years ago to Zeta, and they have a tool to kind of automate schema migrations. It's open source tool, it's called PGRoll. Then I started to become interested back to the basics, going to constraints, because when you create a constraint, it is essentially a DDL operation. And DDL operations might end up locking your databases. Most of them acquire access exclusive locks. So you need to avoid getting access exclusive lock as much as possible. So improvements in constraints are pretty important because this is something everybody does, right? The schemas evolve, you have to change, alter table, alter column. A constraint goes part of that. And this talk will also mention basically what these improvements improve your life, because the less lock you get, the better it is. Lock contention is something that nobody wants to do. If you are interested in this locking aspect, how DDL operations affect locks and how can you avoid it, what kind of techniques there are, you can actually find my previous talks about anatomy of DDL locking. So it's already recorded a few times. You can look it, you can go through it, but this is also kind of continuation about it. That's why I choose the topics constraints. But essentially, these are the rules, right? You can enforce rules about the data that you are storing. There are different ways to do this. There are data types, essentially, right? So data type itself is a restriction. When you have a type, you have to expect data that fits into this type. But they are usually loose, like it's not enough. So you have to enforce more rules. That's where the constraints came. And if you don't enforce this ruling in the database layer, you will probably have to leave everything to the application layer. But my suggestion always is to have, if you can handle things in the database layer as much as you can, you should do that. But there are pretty simple things. And today we will talk maybe more about things that there are really not unknown. Okay, so there were like mentions of Postgres catalogs in the Lightning talks. I remember Michal mentioned it, but in case you don't know what is a catalog, so you store you have a database, right? And you store like information about your products, information about your orders, I don't know, the users and so on. And Postgres itself stores this information about this database in its internal database. So there's this catalogs are in a way system tables that has the information about your database. So there are multiple of them, and PG constraint is the catalog, the system table, that has the information about the constraints. So when you need to find something about constraints, you can go to the PG constraint catalog, query it, is a simple table, system table, and you can see there are a lot of fields there about like, we will talk about enforceability, deferrability, I don't know, validity, all these things can be found in this catalog. And there are many catalogs. If you haven't heard about it, you probably, most of you use it already, but just to give a starter, most known ones that comes to mind, PG class. This is like where the relational information, relations are kept, like tables we use and everything. There is PG attribute. This is about the columns informations. There are PG index, PG trigger, many more. So these are important if you haven't heard catalogs before. Very useful. So I planned the talk that we will go through the description of the documentation of the PG constraint catalog, sentence by sentence, and see what we can learn from only one paragraph in Postgres. I love it because you can just go as deeper as it is. So first is very clear, very simple. It says, PG constraint stores check, not null, primary key, foreign key, and exclusion constraints on tables. If you check this prior to 18, on PG 17, it would say not null constraints on relations are represented in the PG attribute catalog, not here. So that was I was referring that not nulls becoming a proper constraint. Before that, it was not. Anyway, let's continue and see how this actually looks. Another view of looking at what I just said. Each of these constraints are represented as a row. So if you have a constraint, it will be a row in the PG constraint catalog. And the differentiator here that is very simple to explain how many of it we have, how many different types, is the con type. So their con type is like matching with the symbol, right? For check, it is like C, foreign key, not null, primary key, and go on. At the end, there is something called T, which is kind of, what is that? Constraint trigger, and we will talk about it too. These are like not something, I think, when you think about constraints, you don't really think about constraint triggers, at least I didn't. We will talk about it specifically later on. Okay, so the second sentence, it says, column constraints are not treated specially, and every column constraint is a table constraint itself. What does it mean, basically? Why do we have two types of constraints? If you are like, maybe didn't use this before, it would be like some excess knowledge. But let's check what does it mean. So if you are looking from the SQL perspective, there are only syntax differences. So the first one, the top one, has like the price numeric and then check constraint adding to make sure prices are always positive. So that is including only for one column. You just write it after the column definition. That means that it's a column constraint. The second one on the bottom, you write it at the end after the column list, and then it can have more than one column. That means that it can include more. So it's definition-wise as a table constraint in a different SQL syntax. But actually inside, in the representation, the PG catalog, there is no flag for column constraint or table constraint. That's what it was saying in the documentation. So you can actually, they treat them the same. So you can alter these constraints the same way. You can drop these things, so because they are actually the same. And now I want to also show how it looks in the PG constraint. There will be few simple queries that I will show. Please do not try to look at it. I will just mention a few things. They are not important, but later on, after the talk, if you want to run it, you can run it. So I wanted to show here that since we created this check constraints, how do they look inside, and maybe to learn a little bit about the query that I wrote. So I joined PG constraint with PG class because we know that PG constraint now is a catalog that's where we look at the four constraints, and class we learn about relations. And so I joined them by OIDs. And so when I go with conrel ID means that what is the constraints table that we basically where this constraint belongs to in which table. That's what this join does. And I know that in this table set I have in the products October and products November, and I want to see the name, the table name, the constraint names, the constraint type, and so on. And when I queried it, so I see this is the expanded view, pretty much the same. That's what the documentation was saying. They are literally the same. Maybe you notice there is something called conky. That might be interesting if you didn't know. It's just like if I said have, let's say, 3 columns including in this check constraint, there will be their number. So attribution number is the conky. Since both of them only use the first column, the price column, they are all represented with 1, but we can actually have multiple column constraints. Okay, so we keep reading. So we so far didn't really, I think, learn much, but we kind of understood how things looking through the catalog. And the third sentence says, user-defined constraint triggers created with create constraint trigger also give rise to in this table. Okay, so we know triggers, we know constraints. What is constraint trigger? I don't know. So I think it's also not so known, but remember this last entry that we were saying con type T, this is what it is. And we will talk slightly about it to just learn what they are. It was really clear. It said that you can create it as if you are creating a trigger, but when you say create constraint trigger, it's a different thing. What makes, let's like fundamentally think, what makes triggers separate than the constraints? So they have different behavioral patterns. So for constraints, for example, they have a little bit of privilege when, for example, it comes to MVCC. They can see what's happening in the current transactions so that they avoid race conditions. For triggers, they don't have such a thing. They are a bit more clueless, and their firing is immediate. So when you run a trigger, it just does the thing. But when it becomes a constraint concept, you can actually defer this. So I think why we have constraint triggers and what is the biggest benefit is that the concept of deferability. So you can actually defer their execution until the commit time. So you don't need to fire them immediately, because triggers, that's how you do it. Before, after, whenever you are running the trigger, it needs to run. But for constraint, you can actually delay. You can defer these things. And that's important. So that's why the constraint trigger, I think, that's the main difference. And of course, there are like some limitations to it. If you are having a when condition, even if your trigger is trigger is not deferred, but if you have the when condition, it will evaluate immediately. That is something to consider when you are, if you ever use it. I don't think it will be I don't think it will be used often, and I will say why. And they need to be after triggers. Because why? When the constraint is about validating something, so there needs to be some data that needs to be validated. That's why they need to be run after. And similar thing for each row. Constraints validate row by row, so you can't do it like for each statement, but per each row. So that's another constraint. And why I don't think that you will use it, because Postgres internally uses this for how referential integrity works for the foreign keys. So they use this constraint triggers actually to enforce constraints. And that's why we don't really use it in the, I think, user-defined way. It's very rare, and I don't think we really need to, but it is there. And if you don't know Lawrence Alve, he has a really good blog about what I briefly mentioned, that the behavioral differences of triggers and constraints in terms of MVCC, and he also gives an example where it might be useful to actually use a create constraint trigger. But what I like from his blog, that he refers to them as deferrable triggers. He opposes the idea of calling them constraint triggers. They are actual triggers, but you can defer them. So that's why I think from now on I also want to refer them as deferable triggers. Yeah, so if there's a use case that you wonder how it's used, check Lawrence's blog. This link refers to there, so you can check it later on. Okay, and we came to the last sentence. And after this, we will talk about what happened in Postgres 18. This is the last bit about this generic information. At the end, it says, check constraints on domains are stored here too. So what are domains and why they have constraints and why do we store them? There's another debate. If you are looking at the patches including constraints, there is always this like, what we will do with the domain constraints? Because it's something like, it's not a table constraint. Usually constraints are for tables, but some types like a domain itself is a type which we will see, and there are constraints on top of that too, and this catalog will store them too. So I think this is also not very well known. When I asked in Riga if people used domains before, I didn't see many hands. I don't think it will be very different here too. So what is a domain? I think when you put it simply in the SQL statement, it's very easy. They are like types based on a type. So there's a base type, let's say integer type, I don't know, string type, whatever. And then you add constraints and rules on top of this, and this becomes another type as itself. So in the example, for example, I'm creating a domain as an email address, and I have the check constraint attached, and it's checking if the email is valid or not. It will error out, or it will accept the email. So in this case, when you look at it, you wouldn't know that email address has a constraint itself, so it's kind of hidden, but this is stored in the catalog. So I want to show how it looks. In this query, again, as we know already, a PG constraint, but I'm joining it with PG type because that's where the types informations are. And maybe you notice that I say contype check constraint because we know it was saying in the documentation that check constraints of domains are stored in the catalog, so I filter it that way. And I say contype ID is non-zero. If it was 0, that would be connected to a table, then we would have to go with conrel ID to the attached table to see where it is attached. But when we connect this, we know that it's a domain. And I can actually see in the query, there is this, like I forgot to mention in the previous slides, PG get constraint F. This is a definition that we can get the definition of the constraint by this construct and see in the query, I actually query like all the connection name, constraint name, domain name, and so on. But it is cool, basically, to actually open up our horizons that like constraints are not a concept only goes for the tables. I think that was something that I didn't think before, and I think it's worth sharing, perhaps. Okay, so far what we covered. We talked about like catalogs, and we've seen some simple queries, table constraints, column constraints, constraint triggers, and the last we finish with the domains. From now on, we will talk about what happened in the Postgres 18. So there's this very scary list that I just put here, not for you to read, but to see how much work that goes into Postgres every time. I mean, if you see the release also of PG18, it's just like super long. And this is only one part of it that only is related to constraints, and it's not even all of it. It's just the titles of the commit messages, and the history of the work can go many years back. For example, not null work, as far as I know, the debate started around 2010. It was reverted in the PG17, and then finally, after how many years, 16 years or 15 years, went into the code base. So I think it's important to acknowledge like the things that we are using done by real people with years of experience. I think it's worth to at least think about what they are. Okay, so I think the main thing is a very new thing for Postgres, as I said in the beginning, is about introduction of the temporal keys. And before that, I wanna maybe stop and talk about what makes a database temporal. Because the way that we think about databases is mostly relational model. I assume that's what we are mostly using it. I never had to use a temporal database, but it is a different type of model. So I want to explain a little bit about what I learned just from this. And let's talk about it. So first, there are a few criteria. If a database fulfilling this criteria, we can consider it a temporal database. So to my surprise, so I learned a new term a year back, because there was a speaker coming to Prague Postgres meetup. He's a professor, he knows temporal databases. So his talk was about temporal databases. At that time, we didn't have the temporal keys, and he explained how we do temporal data modeling in Postgres before the introduction of the temporal keys. So it kind of like gave me the understanding, okay, Postgres again is capable of doing something that I didn't even know or think about how to do, which is now getting a bit better supported, which is this purple 2 lines, which we will talk about. But the rest was already kind of there. So first thing to know about temporal databases is the first criteria that all databases has to fulfill if they are temporals. A time period data type, including the ability to represent time periods with no end. So that is the first criteria. What does it mean? So in the SQL standard, there is some data type called period, which we don't have in Postgres. But what we have is like range types, like, I don't know, TS ranges with the time zones and so on. So this is enough. So the same functionality is already there in Postgres, and we can have ranges can be, infinity, can go up to unbounded ranges. So that we already fulfill. The second thing to know about temporals is that they don't consider time as like kind of how we store time, right, in databases. We have the time, we just treat it as a metadata, but for temporals, it's the dimension that they are modeling the database around it. So every row, every key that they call has to have an information and period, validity time. So that's what makes it different. So you can see things over all the time. For the same business key they call, you can see more validity time during all the time. They can differ. So depends on when you look at the database, you will see a different information for the same thing, which we will see in the examples later on. It's not as hard as it sounds, but it's a different way of thinking about the data and different way of modeling. So this, we have parts of it. So I say it partially covered, because what we have valid time concept in Postgres. We can use this like ranges, we can put constraints on top of it, and now with the new keys, we cover this part. But what we don't have is that the system maintains transaction time, basically. We don't have it. Some systems have this like system time as of, I think probably Oracle users, I can't remember, but might have. Some other database management systems have it. Postgres don't have it yet, so we don't cover that. And the bottom two temporal primary keys, unique keys, and the temporal foreign keys is the new introduction. So we have that already now, which is good. The rest, I will not talk much about it, because they are different, because the way that you query temporal data is different. The way that you modify temporal data is also different. And the way you delete the temporal data is also different. So each of them requires a different criteria. For example, when you update it, that's why we don't have that. How do you update it? Because when you want to update the data, in which period that you will have to change this? Because you can't anymore say, okay, update this row ID and change it with this. No, because that ID have different lives, kinda. So it's not a one-time life. It's multiple lives. So that's why it's different updating. And Same with the deleting. How do we now delete? We just find the row and we delete that row. But in the temporal, you just update the end range of it. So we are talking about ranges of information, ranges of periods, basically, and we just close that, one of them. And that's how actually we deleted the validity, ended the validity, and that's in a way it's deleted, but we actually keep everything. So that allows you to have history tables. It allows you to see things temporarily. So it's a different way of thinking. Okay, and what I learned from Boris Novikov, he was the person that I referred to who studies about and researches about temporals, and he said something that stayed with me I wanted to put here. Queries to a temporal database return facts that were, are, or will be actual at a time that may differ from current time. So this is the concept that I'm trying to basically display. So as we said, for this model, each data row has an associated time period. The periods are closed and open, and there is a concept of business key. What is a business key? So for example, you have a product ID that you want to see over all the time. So that makes your business key. That is the thing that you want to look through the time. You always want to learn this information. That is your business key. And when you add a validity to this business key, these periods of the same business key can never overlap. So that's what the primary key that we will talk, unique key and the foreign key will actually introducing to make sure this main criteria of temporals, they can never overlap. I think that's enough for now about the theory, and I just want to show a simple example. So what I do here is I'm creating a rooms table, standard, there's a room ID, and then we can consider this as a business key if we want to, and there are room names. And then there's bookings table, and I want to have like a during column, that's where these bookings will be valid. And what I have is like a range, because that's how it should be for primary key to include these things. One of them can be scholar, room ID. The second last column that we can only use needs to be in the range types, and then you can actually say without overlaps. So this is how we can write the temporal primary keys now, and this will make sure that not this for the same room ID, there will be no overlap. And maybe you noticed as well, I'm using an extension, GIST B3 GIST extension, because they are not using standard B3, but they are using GIST. Why is that so? Again, when I was researching about it to learn a bit more, I learned GIST was already having this functionality. So they were able to separate they were able to make sure there is no overlapping if you choose a business key. So this was already in GIST, and they were used by like using GIST and exclude constraints, because the range operators still we have like contains, overlaps, non-overlaps type of range operators. So this was already done that way. It was much more, code, but it was there. So now we have the extension. We also have the native support that brings it to framework that we know, foreign keys, unique keys, and so on. It's much easier, but it was already available through GIST and using exclusion constraints. Okay, so when I want to simply, I want to have two rooms. One of them is blue room, 101. One of them is green room, 102. So for the blue room, I want to insert two values there. So from 10 to 11 and from 11 to 12. And now if I want to insert to this blue room a time range that is included already. It was in the first line from 10 to 11, and now I'm trying to insert from 10 to 10:45, I can't, because I can't have the same room for the same duration. So it actually errors, and it's really clear error. It says that, okay, well, this actually conflicts with this, and it conflicts exactly with that one, you can't use it. And if you want to enter the green one, because we don't have anything for it, it just goes ahead. There is one limitation, since it is a new implementation, you can't enter empty ranges, as you see in the last statement. I'm trying to, from 12 to 12, it's an empty range. It doesn't allow it, because it's kind of, getting complicated. So this was not part of this initial implementation. And to summarize, basically, as I was saying before, in the purple lines, this is how people were doing it. They were using exclude using GIST. For the kind of opposite when you say exclude. So for this during, there is no overlap. It makes sure for room ID, for this room ID, that's the business key, there's no overlap. This is how it was done. But now we do it differently. I think that's enough for the summary. Okay. And for the foreign keys as well, I wanted to show it's different, that there is this period clause that comes from, and why actually normal foreign keys are not enough. So the way that classic foreign keys, how they work, for every referencing row, there needs to be a reference row with the same key, right? That's how we combine them. But here now, if I'm thinking equality, it will not work. It needs to be valid for the period. So there's a range. So it doesn't have the equals, but also containing. So if these periods are containing each other, that's a different way of thinking. So that's why we need this. And the way that we now do the referential integrity for temporals comes with this period clause that I show. So if you imagine it, then I would have a bookings table, which I already showed, and a room availability table. Then I know that the booking is valid during the time range, the same time range. A room is available during the some time, and then booking is valid only if it's entirely within this availability. That's what this kind of represents here. Okay, so now we stop with the temporals. How is it going so far? I think it's like, I hope it's going well. So yeah, temporals are a big topic. I think I'm really, really excited about it, that it will go probably more than that. We'll see more support to it. And the next thing is not enforced. Why I'm exactly excited at not enforced? Because when I see first mention of not enforced, I was like, what does it mean? Like, what does not enforced mean? Because I think all of us can understand not valid, what the reason of why we have not valid, right? When you have a constraint, if you add it directly, let's say you are adding a not null, you have to make sure that like there will be, you can have a table rewrite if you are adding some constraints, right? Or you need to validate this thing. So if you add it directly and not with adding with not valid, if you don't have the opportunity of not valid, the moment that you had this, it will create some scans, and you try to avoid it. So if you have something not valid, that's how we were doing it before. You were separating the DLs, like let's say you're adding a check constraint as like not null, and then validating it, because the validating doesn't take a strong log, and then you are just adding a not null. So there were like kind of things that we do for it. But now we have not valids for some statements. We can use the not valid. What is not enforced is that kind of taking it a further away from this logic, right? Further ahead, not away, but further ahead. In a way, it doesn't enforce anything. So you have this, it's like defined there. I think it is actually useful to probably signal what is the intended state for the optimizer and something, but I didn't really research about it. But it's important to show where is the data is going, so you can actually plan stage rollouts. But yeah, so for me, it was like at the beginning, okay, what is this? So it's a new flag for the constraints. Then we can now, for example, I showed it here. If you want to add the constraint, for check constraint, you can do not enforced. And then there's a new, in the PG constraint, there's a flag there. If it's not enforced, it is how it is. But I think it was not meant mainly for check constraints, because I think invalid will be already good enough. But what is actually better for in the evolution is the not enforced concept for foreign keys, because you can actually defer this validation to later on. That's important for foreign keys for sure. So if you create a foreign key now, not enforced, what does it do? For every foreign key, there are like triggers that are created in the background. And if you create the foreign key as not enforced, basically there is no integrity check at that point. So you have a foreign key, but you actually don't have the foreign key. And then at the beginning, they are marking it as not valid if it's not enforced. But you can change this behavior, right, from not enforced to enforced. And then what will happen? If there's the missing triggers, then they will add the triggers, and then the constraints will be changed to valid. That validation happens then. So you know this, that will trigger a validation. And if it was something enforced and you want to change it to not enforced, so what does it do? That it will delete these triggers that make sure this integrity checks. And then it makes the constraints as like not valid. So it's a bit like, I mean, it's a good advantage, because for systems that will actually benefit from this, is amazing. It's one step ahead of validation, but that's why I wanted to put it here. I think it's more important for foreign keys than the check constraints for sure. So this is another topic. It's a bit kind of smaller relatively comparing to the other topics, but string comparison in Postgres, as all of you probably know, depends on the collations. And we are here in this, we are trying to make sure if a primary key and foreign key, either they are using all of them, both of the parties, deterministic collations, or if not, both of them needs to use the same non-deterministic collation. So this might be why I put it here. If you are updating, if you are using PG dump and PG upgrade, this might create maybe problems for you. So check the collations before if you do PG dump and PG upgrade after. So that's something to maybe mention. And we are almost coming to the end of the talk slowly. And this is another big changes group, not null. What happened to not null? Alvaro has, he's like the main developer for this patch. He has a really nice blog in the EDB blog. If you go there, he explains actually history of the changes, why it matters, why it's important. So I recommend for you to read it. But I will summarize here what changes when you are not anymore in PG attribute, but now you are in the PG constraint. What changes? First, you get a type, not null n. And now when you just /t, you can actually see the not null constraints as well. Although they are debating because now it's really busy, like all the not nulls appearing in the description, that might change. But now you can do that. You can, once a thing become a constraint, it will actually help for all the constraints because now we can treat them similarly. The tooling that uses constraints will actually use them separately. They were checking the attributes and constraints. They don't need to do that anymore and so on. As we said, constraints, I think, biggest advantage is how we propagate these things. So then we can think about inheritance, how we create the partitions, and so on. And I will explain a little bit how this works for the not null constraints now. And yeah, this is too much text. I wanted to show it later. OK, so first thing, not null now can do not valid. This is a really important step. As I said before, we were doing dances around how to not to get low contention, how to reduce the contention, how to plan these things. Now we can just add the constraint not null as not valid. That's already really good, so you can avoid scanning the table. And then you can validate it later, you can plan it, so it's good. And how the inheritance will work then, you can also think about inheritance because it's a proper constraint, has the inheritance capability. So if the parent is valid, it can't, their children can't be invalid. That is similar to the behavior of how enforcement works. So this is the same, matching the same behavior. There is a new, it's exactly shown in the validity, convalidated. You can check from there. And the rest, you don't really need to worry. So PG dump, PG restore doesn't change for it. So you don't need to think about that. And another thing, now you can create something with the different behavior of inherit or non-inherit, and you can change it. So you can this now allows modification of the inheritability. So how does it work? I just wanted to maybe briefly mention this inheritance business too. So if you don't have like when you do alter table, alt constraint, you can set basically you want inheritance or not inheritance. So if you want to change from non-inheritance to inheritance, it's very easy. It's just adding the missing constraints. But if you are changing something from inherited to non-inherited, in a way, how does it work? How the starting work looks, the parent has the constraint, then it is marked as the local constraint for it, and then nothing is it is not inheriting that constraint from anybody, but when you look at the child, it is inheriting from that. So that's why the inheritance count is 1, so there's 1 line there, and it is not local because it's inheriting from the parent, right? So when you want to remove this relationship, basically you can't ancestor line is gone, so the parent becomes something independent of the child. Child, if they want, they can keep their constraints. Postgres doesn't matter for that. The parent anymore doesn't become the parent. So if I remove this from it, the new inheritance will be not having this constraint, basically. OK, so as I said, I want to show what changed for the partition tables, because I know many people are using partition tables, and they are also kind of neglected usually, like things happen to normal tables, and partition tables follow later on. Now we have the option to have not valid foreign keys for the partition tables. What I mean is for the parent. Basically, partition table is the parent. Partitions are the children. So now you can actually do per partition validation, which is amazing because when you create a partition, the foreign key checks could happen immediately, right? Now you can actually validate them independently. Later on, you can actually defer this as well. And if you want, you can run it for everything in the hierarchical top level. So you can actually validate all the partitions or run partition by partition the validations, which is also good. And eventually, I hope this will also allow the not enforced coming to these partitions as well from the foreign keys. Okay, another thing that's really important. Before, I think this was kind of mistake. This was not an intended behavior. We were not allowing actually dropping constraints only from the parent table before. It was when it was implemented, it was kind of, I think, not taught properly. Now it's allowing. So if you want to drop a constraint from the parent only, you can do that. So the constraints can still keep their constraints, but you can actually drop from the parent. But if you want to add only a constraint to the top, this restriction still stays because you can't imagine a child that doesn't have, like, you can't imagine a parent that has only the constriction itself, because if something is inheriting this behavior, it will inherit. So that's also, I think, fixing something that is not taught well before, I think. Okay, so we are literally almost at the end. I know that it was a long, literally full text, heavy presentation. Thank you for bearing with me. Okay, and I also looked at Postgres 19. So this was all for Postgres 18, but I wanted to see what type of pages are happening, what are people talking about, and I listed a few of them here. The first one I think is really useful. They are working on a command, PSQL command. It may change or maybe not even, any of them might not end up in PG19, but it's in the works. DCS, so it will actually list all the constraints for all the tables. That is the plan. It's good. I think now you could know how we were doing it. You could either look at the PG constraint, or you can actually go table by table, see their constraints. But this one will actually list all the constraints. So I think this is really good. The other thing that we are working is like check constraints when you run an update. Update was actually running check constraints for even if the update is not involving any column in the check constraint. So all the check constraints were actually being touched. So now they are thinking that how we can actually look at it, that because we know this dependency is between, if the column is not involved in this check constraint, we shouldn't be bothered by the updates, which is also good. That will save us, good time. And the third thing is support fast default for domain with constraints. What does it mean? Basically, there are things that you can do fast defaults, like kind of metadata operations, and they are working on that. And as you see during the whole presentation, I mentioned that maybe this will pave the way for the not enforced, because now we talk about the not valid for a constraint, and then the next step is not enforced. So there was this not enforced debate. Maybe it will also go. So it's good to see, things continue, and we will have more and more things added for the constraint front in the Postgres. Okay, and I wrote a blog about the topic. If you scan this QR, it will go to where I work, Zeta's blog, and I wrote about constraints a lot because of this. So I hope you will find it useful. And if you want to have anything, I will be here whole day, and I know that we will have a coffee break, so just come find me anytime, or you can write me from my email. Having a unique name is easy, that people can just write your name and company, and then they can find you. Thank you for staying here, and I know it's late, and I appreciate all of you. Thanks.
So if anybody has a question, we still have some space. Yes.
Hi. So when we
Hi,
have
Damir.
a constraint marked as not enforced, and then we enforce it.
Yeah, I will show you there.
Yeah, suddenly we have nice triggers and everything's marked valid. What I'm missing here is there some kind of validation on that point? Or from that point on, we
are actually checking it. So
and we are trusting the old data.
Yes.
Okay.
Okay, so no more questions or questions at a coffee, which you can take outside. And we will meet here in basically half an hour. So 45, the next session about vacuuming the tables is starting.